So neighbor relationships are active, but no routes are being advertised by either neighbor. We can look at the BGP table by using the command show IP BGP. And what you'll notice is that no routes have been added to the BGP table. There are two ways to get routes into the BGP table. You either redistribute routes into BGP. So you type redistribute and you redistribute routes from a routing protocol such as OSPF, or you use the network command. And that's what we're going to use here. So we're going to advertise network 17.17.17.1. This network has a /32 mask. Now it's really important that you get the mask right when advertising routes into BGP. So I would suggest that you use the command show IP route, confirm what the actual network looks like in the routing table, and then match up your network command to that entry in the routing table. So this network has a /32 mask in the routing table, so I've used the /32 mask in BGP. So now when I type show IP BGP, notice the difference. BGP table version is now 2 because a route has been added to the BGP table, so change has been made. We have a route in the routing table of 17.17.17.1 /32. In other words, this network, which was directly connected in the IP routing table, or RIB, has been added to the BGP routing table to be advertised to neighbors. Previously on router 2, when we used the command show IP BGP summary, no routes were received from neighbors. But now show IP BGP summary shows me that one route was advertised through BGP, and the command show IP BGP shows me that we received a route from router 17.17.17.1, this router, through BGP. So on router 1, this network with a next hop of 0.0.0.0 is in the BGP routing table. The next hop is set to zeros because the local router advertised the network into BGP. On router 2, however, we can see that the next hop is 17.17.17.1. In other words, router 2 learnt about that network from router 1. What you can also see here is star and greater than sign. An asterisk or star means that it's a valid route. Greater than sign indicates best route. A valid route means that the neighbor who's advertising the route is reachable in the IP routing table. In this example, we're not seeing that. We're seeing an R, which means RIB failure, and that's because OSPF is also advertising that route. OSPF has a lower administrative distance compared to IBGP. IBGP has an administrative distance of 200. In other words, OSPF took precedence over BGP, so BGP is indicating that it wasn't able to put this route into the IP routing table because another routing protocol was deemed to be better or be more reliable than IBGP. eBGP has a lower administrative distance than OSPF. It has an administrative distance of 20, but in this case, because these two routers are in the same autonomous system, IBGP is used, which has an administrative distance of 200. In other words, it's seen as a worse routing protocol. So what have we configured? Show run section BGP. On router 1, we configured BGP in autonomous system 17. We specified a neighbor, router 2, in autonomous system 17. We specified that we are going to talk to that neighbor using the loopback interface, which is good practice when using IBGP, in other words, BGP within an autonomous system. We also advertised the loopback network to router 2. Router 2 has something similar configured, show run section BGP. BGP is configured in autonomous system 17. Neighbor is configured to router 1. Loopback is used as the update source. What we haven't done is advertise this network and this network into BGP. So on router 1, router BGP 17, network 17.1.1.0. It's very important that you get your mask right. So let's do show IP route. We want to advertise this network, which has a /24 mask. So network 17.110 mask 255.255.255.0. Notice the mask in BGP is a standard mask, not an inverse mask, which is different to OSPF. In OSPF, we use an inverse mask, whereas in BGP we use a standard mask. For job preservation reasons is how I like to say it. We can't make it too easy. So for job preservation reasons, to make sure that it's complicated, so that we are employed, things are made complicated. So let's look at BGP. Show run pipe section BGP. We've now added this network to the BGP advertisements. We can do something similar to that on router 2. So before we do that, show IP BGP. Notice router 2 has learnt about 2 routes through BGP. Neither is being put into the routing table because more believable routes are found in the routing table. This network is directly connected, and this network was learnt through OSPF. So let's advertise that into BGP on router 2. You don't have to do it on both routers, but I'll just do that in this example. And then I need to advertise the loopback of router 2 into BGP. So show IP BGP. This network is found twice in the BGP routing table, once from the local router and once from router 1. The I on the left-hand side here means that the route was learnt through iBGP. Show IP route. Show IP route shows us that that network is not put into the routing table because it's directly connected. So it wasn't put in using BGP, even though the route appears in the BGP routing table. On router 1, show IP BGP. We now have 4 routes in the routing table. Notice how the BGP revision number has changed. Every time there's a change in the BGP routing table, this number increments by 1. And that's why on internet routers the number is very high, because there are a lot of changes on an internet router that has the full internet routing table.